Hey there, welcome back. This is what some of the students saw when they started class today. This is San Pedro Valley Creek. This is San Pedro Valley Creek about a week ago when we saw some of the biggest water that was flowing down that creek since about 1982-ish. See it in just a second here. And also when you think about what you're seeing the rock cycle in action. Also you're about to see my golden retriever who loves the water, by the way. But when you see the creek this big around here, that's extraordinary. Very cool scene. And that's Cody. All right, so why was I showing that? If you look at San Pedro Valley Creek, one of the things that you're seeing right there is the rock cycle in action. You're watching all that muddy water come on down the hill. And when you see the rock cycle in action, you're looking at one of the things that we are going through weeks 18 and 19. When we do our schedule at the beginning of the year, Ms. Licata is something similar. I usually look at the calendar year. We have 38 weeks of school, but you know as well as I do that, week 38, week 37, the last 2 weeks of the year, not too much in the way of academics going on that week. I still try and make sure that we fit in every little bit that we can because we only have, so much time to fit in all the biology, all the geology that we're trying to get across to show you what makes Earth such an extraordinary place for life. And when we're doing that, I really try and take advantage of every day. That being said, tomorrow, unfortunately, we have no school. The atmospheric river that's hitting right now is going to cancel classes tomorrow. That means, unfortunately, we won't see our guest scientists tomorrow. But it also is a good opportunity to talk about something that we began the year with. We talked a little bit about probability and statistics. There's a couple of dice right here. The students were rolling dice way back in September. We were looking at making a bell curve, all the ways that you can make either a 2, a 6 or a 7, or a 12. And when you roll the dice, you might remember that it's much easier to make, say, a 6 or a 7 than it is to make a 2 when you add up the values on the 2 die, or a 12. Because, of course, there's many more ways to make, say, a 6. You can do a 3 and a 3, a 4 and a 2, etc. Well, there's only one way to make 2. Snake eyes, double ones. And when you're talking about all the places that math and probability and statistics comes into play in science class, it amazes me. It actually is stunning, all the places that it shows up. When you look at, for example, Punnett squares. You've got Punnett squares right here. You've got probability crossovers with the math classes across the hall, talking about the ratios of, say, male versus female when you're doing a Punnett square on X and Y on the gender. It shows up again and again. I'm always stunned by all the places that probability shows up. And our weather is a good example. The NOAA, National Oceanographic and Atmospheric Administration, said that this was going to be likely a very dry December and January. A lot of people point to that and say, well, see, they can't predict the weather. They're very, very good at predicting the long-range forecasts. We're very good at predicting what's going to happen over the long haul with our climate. The thing is, it's a little bit like loading the dice. You can make a statistical guess about what it's going to be, but actually nailing what is really going to happen, well, that's another matter. And so what we're seeing right now, even though it's a La Nina year, the ocean is still relatively cold, at least up through February, according to the projections. It looks like we're kind of lucking out with putting a huge dent in our drought here in California. When you're looking at the entire 38 weeks of this class, at the very beginning of the year, we started talking about things like the age of the universe, chemistry, a little bit of geology, a little bit of the formation on Earth. That was all designed to get to really what we're doing right now, which is weeks 18 and 19, meant to be a good review, a good coming together of everything that we've done. And then as we go forward with weeks 20 on to the end of the year, we're looking at the specific things in biology, for example, the structure and function of plants, the structure and function of fungi, the various kingdoms of living things, and specifically the organ systems in the human body. So when we get into that, hopefully we've laid the groundwork chemistry-wise. When you're looking at the Earth as a whole, we'll get to the notes of today in just a second. Remember the Ian Stewart movie. I'm just showing a 10-minute clip from it today as a good kind of backup and reminder of where we've been. He does a fantastic job, and I'll try and link to it down below, of talking about the extraordinary series of events that made life on Earth, complicated life, possible. We might have a galaxy full of one-celled organisms on different planets and moons where the conditions are right for life. but big complicated life. When we say complicated life, the things like humans that are out there looking for other life in the universe, that might be very, very, very rare. And you look at all the things that it takes to make life possible. In other words, if this is about the size of our planet right here, Mr. Stewart points to at least one big event, which was the impact which created our moon. Now, our moon, of course, relative to the size of the Earth is about that big, but it's much further away if I were to draw it at this scale. But the moon stabilizes our orbit. You're looking at the impact that made our moon a few billion years ago, adding just the right amount of mass to our Earth to help us maintain an atmosphere. You're looking at the most important, in my opinion, thing about our entire planet is that we've got enough internal heat from the radioactive decay of elements and from leftover heat from the gravitational potential energy, which was all impacted from the asteroids and comets that hit and formed our planet. When you're looking at that internal heat, it drives the rock cycle. If it wasn't for that rock cycle, we wouldn't have the extraordinary fossils, we wouldn't have the recycling of materials on the Earth, we wouldn't have one of the key conditions that make big, complicated life possible. Again, we might be living in a universe that's filled with simple one-celled organisms, but might be in a universe that has civilizations being extraordinarily rare. We were talking a little bit in the earlier part of the year, that's why we used the movie The Martian, one of only 2 movies that we use all the way through because it's so good and it hits the standards so well. When you saw The Martian, you were looking not only at Newton's laws and things like that with the ship going to Mars and back, but you're looking at the reason why we have life here and not on Mars. We're making a little bit of fun of Elon Musk. Why? Kind of deserves it. If you look at Occupy Mars and sending colonies of humans to Mars, you're looking at sending people to a cold, dead rock in space. Now, rock like this is basalt gathered from the Sierra Nevada mountains. Mars does not have a rock cycle. There are a lot of dynamic processes on Mars. For example, there's a big mantle plume on Mars. We think Mars has more internal heat than we originally thought, but there's no rock cycle. There's no atmosphere to speak of other than carbon dioxide, which is held very loosely by the weak Martian gravity. You're looking at essentially taking billions of dollars or more and trying to sustain human beings on a rock in space, where if you want to put resources towards something that's really useful, you would take billions of dollars and put it to maintaining the ecosystem that we're learning about, the ecosystem we have right here on this planet. The ecosystem that it's hard to overstate the human impact on that ecosystem, from our atmosphere to our current extinction that's going on. So that's one of the main themes of 7th grade in the California standards and the national standards, the human impact on the environment. That's what we're here to learn about. That's why we're in this biology class in the first place, to learn not only how it works, but how we can be stewards of that environment. So weeks 18 and 19 are meant to be a good review, hopefully, of everything we've done. Unfortunately, we lose tomorrow. That means we do lose our Scientist Day. Sorry about that. My brother moved back to New Hampshire some years ago, and I know back east they have snow days, but then they have to make up snow days at the end of the school year. I don't know if we'll have to make up tomorrow or not at the end of this year, but I want to make sure that I get through the notes right now so that we are not falling behind on where we'd like to be by the end of week 19. For today, we went a little bit through fossils, fossil fuels we talked about. If you look at, let me reach over here, grab, if I can, it's underneath the chair where I'm propping up my computer right here. This piece of coal is a fossil fuel made around 300 million years ago from the remains of once living things. You've got once living things that, while we can burn their carbon, we can use that for heat, we can use that for energy, generating electricity. This is a finite resource. Coal, oil, gas. When I worked at Chevron Corporation, you're talking about taking this and refining it, separating it into its various petroleum products. That's a very limited resource. And then we're talking about the resources on this planet that we can take advantage of, like solar energy, like geothermal energy, the natural heat within our planet, the things that will sustain your generation and the next generations going forward, the things that won't have as big an impact on our atmosphere. When we're looking at The petroleum industry went down to the petroleum industry being really the result of the rock cycle. When you think about it, something that was once living gets buried. They showed a little bit of peat on one of the brain pops that we saw today. Peat is a very popular fuel, for example, used in Ireland. They have peat bogs where they can dry it out, use it for fuel, burn it for heat. Peat is kind of like pre-coal. It's just before it gets to the part where it's under pressure for millions of years and turned into this rock right here. When you're looking at this resource, it's going to run out, but this resource is a result of rocks continually being recycled on this planet. At the very beginning, when we saw San Pedro Valley Creek running out, based on my kayaking days, I would say that's roughly about 1,000 cubic feet per second that you saw flowing through there, which is extraordinary for that little creek. You're looking at a muddy river going out. All that rock being carried from San Pedro Valley and Montera Mountain out to the ocean. If you think about that as going on for millions or billions of years, if there was not something to rebuild those mountains, if there's not something pushing land up somewhere, you would have basically our entire planet having no land on it, being a very relatively shallow ocean, about a mile deep all the way around, and maybe some shallower parts, but no land at all. There's got to be some process that's recycling things, making things go on this planet. And this basalt, this volcanic rock, which was extruded onto the surface of the planet, is a good example of that process. The rock cycle. The rock cycle is driving everything. It's what gives us our information about biology, because the rock cycle puts down the sedimentary layers. The sedimentary layers that we saw really being made right under our noses here in San Pedro Valley Creek with all that muddy water flowing out to the ocean. And the rock cycle gives us our evidence for evolution on Earth. When we're looking through the rock layers, one of our key terms this week, and we've had it before as a matter of fact, the law of superposition, tells us that usually the layers at the bottom are older than the layers at the top. When we're looking at those fossils that are found in each layer, in sedimentary rock only now, when we're looking at those fossils that are found in each layer, we can see how life changes throughout time. That gave us one of our first initial, most important pieces of evidence for evolution. We can look at the fossil record and see how things change over time. Moving over to here, we're going to be looking specifically, starting off with plant and animal fossils, and plants first, excuse me, because when you're looking at the plant fossils, we have a lot of trace fossils of plants, a lot of impressions of what the plants look like. But when you're looking at soft tissues, for example, let me reach over here and grab this piece right here. This is a piece of a pine tree. Most of this will likely not get preserved as a fossil. There are extraordinary circumstances where you can take a piece of wood like this and it can be petrified. You have to have just the right conditions for that. But for the most part, the soft tissues, the cells, the things that are inside the cells that we're learning about, mitochondria, DNA, nuclei, they don't get preserved. So when we're looking at evidence for evolution, we're looking at evidence of change over time. Fossils are our main source of that information at first. Now we can actually see the evolution happen when we do artificial selection, when we're breeding things to get specific characteristics that we want. But the most important thing for seeing the change over time has been the sedimentary rock cycles where we get fossils. What drives that? The internal heat of the Earth. Where does that internal heat of the Earth come from? The radioactive decay of elements and leftover heat from the impacts of asteroids. That brings us all the way back to why at the beginning of the year we're learning a little bit about chemistry, a little bit about the atoms in the periodic table, a little bit about the extraordinary 14 billion year history of our universe. Because it took 14 billion years for a universe to make you, for a universe to have you here learning things in this class that 100 years ago even, any scientist in the world would have been absolutely astonished to hear. The things that we've learned in the last century, hopefully I've made the point over the last couple of weeks, have absolutely changed the face of the world of the last century. So, a recap. We're recapping this recap of what we've done today. We're recapping where we've been and where we're going over the 38 weeks that we have together. And really, I kind of consider it 36 weeks when we look at the last 2 weeks. There's not, again, too much academics going on right now. I would suggest that this would be a very, very good time, if you want to, to get a new notebook going in the class. I know it's hard sometimes to keep an organized notebook throughout the entire year, and I know most students have a spiral-bound notebook like this. Some do have binders, but a spiral-bound notebook seems to be the most popular. And this is a good time when I'm recapping to kind of get down, okay, this is a good map of where we've been and a good map of where we'll be spending the next 15 weeks in class, where we're learning about things like human body systems and the ecosystem. So check out the notes. They are out there online. Check out the calendar there. It's also online as well. And tomorrow being a day off because of the atmospheric river that's heading over California right now. Stay safe, and we'll see you back here hopefully Friday, if not Friday, Monday, or Tuesday. Bye-bye.